Good morning, fifth graders. Welcome to your next math lesson. Go ahead, open up your math notebook, turn to the next available page, and at the top of that page, write the title of today's lesson, which is Greatest Common Factor. Okay, so let's take this word by word. The word greatest means biggest. Common means two things have it in common, so it's in more than one group or in more than one list. And factor means it's a number that can fit into another number. So for instance, let's say we were trying to find the greatest common factor for the numbers 4 and 8. So we're looking for the biggest number that is a factor for both of these numbers. The biggest number that both of these numbers have in common as a factor. So we can list all the factors for both numbers. The factors of 4 are 1 and 4 because 1 times 4 is 4, and 2 because 2 times 2 is 4. Those are all the factors of 4 because they're all the numbers that can evenly fit into 4. Or another way of saying it, they're all the numbers that can be multiplied together to equal 4. 1 times 4 is 4, 2 times 2 is 4, so 1, 2, and 4 are all the factors of 4. Now the factors of 8, 1, 2, 4, and 8. Those are all the factors of 8 because 1 times 8 is 8 and 2 times 4 is 8. So those are all the numbers that can evenly fit into 8. They're also all the numbers that can be multiplied together to equal 8. That's why they're called factors of 8, because factors are numbers that are multiplied together. So these are all the numbers that can be multiplied together to equal 8. So they're all the factors that can equal 8, or the factors of 8. Now we're looking for the greatest common factor. That's the greatest number that's in both lists. The biggest number that 4 and 8 have in common as a factor. So all we have to do is look and find out what the largest number in both lists is. Now 8 is the largest number, but it's not in this list. So it's the greatest factor, but it's not the greatest common factor. The biggest number in both lists is 4. So the greatest common factor of 4 and 8 is 4. Now, that's one way of finding the greatest common factor, but it's not the easiest way. Because what if you had to find the greatest common factor for the numbers 40, 24, and 32? What if you had to find the greatest common factor for more than two numbers? There's 3 in this list, and they're kind of big numbers. You wouldn't want to have to list all the factors for all 3 of these numbers. So I'm going to show you an easier way to find the greatest common factor, and I'll show you with these easy numbers first. What you do is you do the prime factorization for both numbers. And prime factorization is something we've already gone over this year, but there's a pretty good chance you've forgotten how to do it. So I'm going to go over it very slowly with you. When you're finding the prime factorization of a number, you're listing the prime factors of that number. So we start by, you're probably going to remember this now, both numbers sprout branches. Now you can pick any 2 numbers in the world that can be multiplied together to equal 4, except you can't pick 1 and 4. So you could pick 2 and 2. And we're actually done with the prime factorization of 4 right there, because 2 and 2 are both prime. That means they don't have any factors except for 1 in themselves. Now for 8, we could do 2 and 4. Now 2 is prime, but 4 isn't, because you can multiply 2 and 2 together to equal 4. Now the prime factorization of each number is done when there's nothing left except for prime numbers at the bottom. Now we can use this to find out what the GCF, or the greatest common factor, is for 4 and 8. We take each number and we write it as many times as it's in both lists. Watch. 2, here's a 2, and here's another 2. It's in both lists one time, so we write it down here one time. Here's a 2, here's another 2. Since that's in both lists one time, we write it down another time. We don't write 2 again because even though there's one more 2 in this list, there's nothing to match it over here. We can only match 2s twice, these 2 and these 2, so we write 2 2s in the list. Whatever you have written in this list, you multiply it together. 2 times 2 equals 4, so 4 is the greatest common factor for 4 and 8. Now I'll show you with a more complicated example. Let's say we had to find the greatest common factor for 40, 24, and 30. So I'll put 40 here, 24, and I think I just said 30, but it's actually 32. We're finding the greatest common factor for 40, 24, and 32. So we're not going to list all the factors for all 3 of these numbers. That's too much work. So let's use prime factorization. Each number sprouts branches, and you pick any 2 numbers that can be multiplied together to equal these numbers. So we could pick 4 times 10. And then we keep going. They keep sprouting branches until there's only prime numbers left. 2 times 2 is 4. 2 times 5 is 10. There's only prime numbers left because 2 is prime since only 1 times 2 equals 2, and 5 is prime since only 1 times 5 equals 5. Here for 24, we could pick 3 times 8, or we could pick 4 times 6, or we could pick 2 times 12. I'll do 2 times 12. 2 is already prime, so it can't sprout branches. 12 is not. 2 times 6 is 12, and 2 times 3 is 6. Now these are all prime numbers left. And for 32, 4 times 8 is 32. 2 times 2 is 4. Those are both prime. 2 times 4 is 8. And 2 times 2 is 4. Now we have all prime numbers left. Now we write a number down for each time we can match it in all 3 lists. So we have a 2 here, a 2 here, and a 2 here. So we put 1, 2 here. Let's cross those out now since we know we've already used them. We have a 2 here, a 2 here, and a 2 here. So that's another 2 we can write down here. Let's cross them out now since we've already used them. We have a 2 here, a 2 here, and a 2 here. Let's cross those out now since we've already used them. Now, we have a 5 here, but nothing to match it here or here. We have a 3 here, nothing to match it here or here. And we have 2 2s left over here, but there's no 2s left here or here. So we don't write anything else. Now we multiply 2 times 2, and whatever we get right here, that'll be our greatest common factor. 2 times 2 is 4, times 2 is 8. So the greatest common factor of 40, 24, and 32 is 8. That means it's the largest number that can be used as a factor to get these 3 numbers. It's the largest number that's a factor for all 3 of these numbers. Let's do another example together. I'm going to go ahead and turn it over. Oh, and one thing I think I forgot to mention is that we're finding the greatest common factor in this lesson, and that can also be shortened to GCF, greatest common factor. Let's say we had to find the greatest common factor for 24 and 60. Now we could list all the factors for both those numbers and then pick the biggest number that's in both lists. That would take a long time. Or we could use prime factorization. So 3 times 8 is 24. 6 times 10 is 60. 3 is already prime. 2 times 4 is 8. 2 is prime. 2 times 2 is 4. Now these are all prime. 2 times 3 is 6. Those are both prime. 2 times 5 is 10. Those are both prime. Okay, now we have a 3 here and a 3 here. So we put 3 in the list once, and we cross those out because we've already used them. We have a 2 here and a 2 here. So we put 2 in the list once. We have another 2 here and another 2 here. So we put 2 in the list again. We have 1, 2 left here. Oh, yeah. Yeah, I forgot to cross these out. We have 1, 2 left here, but there's nothing to match it over here. And we have 1, 5 here, but there's nothing to match it here. So we're done. Now we multiply these numbers together. 3 times 2 is 6, times 2 is 12. So 12 is the greatest common factor for 24 and 60. Let's do another example. Let's say we had 18 and 42. Now, you could list all the factors for both these numbers and then pick the biggest one in both lists, but it would take you a long time, so it'll be faster to use prime factorization. Make them both sprout branches. 2 times 9 is 18. 2 is prime. 3 times 3 is 9. 3 is prime. So we're done here. It's 2, 3, and 3. Now, 6 times 7 is 42. 7 is prime. 6 is not. 2 times 3 is 6. And again, why is 7 prime? Because only 1 times 7 equals 7. Nothing else can be multiplied together to equal 7. Okay, now we have only prime numbers left in both lists. So we start matching them. We have a 2 here and a 2 here, so we put 1, 2 in the list. We have a 3 here, and we cross those out when we're done. We have a 3 here and a 3 here, so we put 1, 3 in the list. We have a 3 left over here, but nothing to match it here, and we have a 7 over here, but nothing to match it over here. So we're just multiplying 2 times 3 together, and that's 6. So the greatest common factor for 18 and 42 is 6. Next, let's do another one together. Let's say we had 4, 10, and 14. We have 3 numbers this time. And so that would make it kind of hard if we had to list all the factors for all 3 numbers. It actually wouldn't be that hard with these 3 numbers, but it'll be faster to use prime factorization. 2 times 2 equals 4. Those are both prime, so we're done. 2 times 5 equals 10. Those are both prime, so we're done. 2 times 7 is 14, and those are both prime, so we're done. Now we list numbers. Now we match numbers in all 3 lists. 1, 2 here, 1, 2 here, and 1, 2 here. So we put 1, 2 in the list. Cross those out. There's a 2 here, but nothing to match it here and here. There's a 5 here, but nothing to match it here or here. And there's a 7 here, but nothing to match it here or here. So 2 is the greatest common factor for 4, 10, and 14. All right, I think I'm going to give you some to try independently now. Let's see, how about 30 and 72? Find the oops, you can't even see it. Find the greatest common factor for 30 and 72. And then also find the greatest common factor for, let's do 9. Find the greatest common factor for 9, 18, and 42. Go ahead and see if you can find the greatest common factor for 30 and 72 and the greatest common factor for 9, 18, and 42 independently. And then click on the video attached below this video to see if you did it correctly. I will see you there.